We start, we kind of have to have a conversation. So Mr. Stouffer and I have been trying to figure this out for like the last 2 weeks, and we spent way too long on this. We've been trying to think of out of the box solutions to be able to finish on time. And this is kind of the only fair-ish one we could come up with. Because our only other options really were to like either A, not finish, which we didn't like that option, or B, like have you do some outside of school if you wanted to finish on time, and we didn't like that option either. So the main thing we had to work with is there's only 18 more times that we're going to meet together before the AP test, which is really strange. So it's May 9th, and we're still in March, but we're only going to meet 18 times throughout April, because April is just really messed up in terms of days. There's ACT testing, there's MCA testing, there's flex day this Friday, there's wind days. Like, we just lose a lot of time, little bits at a time. And every time we take a test, that usually takes at least 2 to 3 days per chapter. And so with this kind of a schedule, it just wouldn't work. So we're kind of just going to go straight through, and we're going to cut out anything that's unnecessary, which is very little. I mean, like, pretty much the curriculum that you have already is pretty much the basics of what's on the AP test. But we'll cut out things that are just not really going to be necessary. And that should allow us to finish, or if anything, maybe a section not done. But like, say, every single year, the free response section, one of the 6 questions is on volume, and that's the beginning. That's at the beginning of Unit 8, and so it's kind of almost impossible for us to just like chop that part out, but then expect you to still do well when it's a 1/6 of the free response points. And so we'll be able to get to that now with this setup. We're not going to have any time to review together, which honestly we'd like to do, but we just really won't be able to. And there's lots of options for you guys to review. There's Barron's book, which I believe I've shown you. We've used a little bit. There's Khan Academy, the AP Classroom, and then AP has their own YouTube channel too that they've done in past handful of years to prep people. So they'll have like a video that outlines each unit. I went through AP Classroom and I opened everything up. Is that what you're going to ask?
No.
Okay. So I opened everything up in AP Classroom, so you're able to view, take anything in there that you'd want. I'm not super proficient at AP Classroom. I'm not sure if you take it one time, if it locks you out again, or if you're allowed to do it more than once. If it does lock you out, let me know and I'll try to figure out how to undo that. And then after the AP testing is when we'll go and do our assessments. And we're not going to like just take them 3 days in a row or something. Like, that would be dumb. So what we're going to do is we're going to do like 3-4 days of review and then take the test. 3-4 days of review, take the next test. And then you guys will be able to use your packets and notes on it. So we thought that was kind of a pretty fair trade-off to try to help you out. I get that you didn't really have any input in this, so it was kind of just, we had to try to figure out something for everybody. So I don't know. Do you guys have any thoughts on this, or upsides, downsides? That it's not gonna hurt my feelings if there's something you don't like about it, but does it seem okay to you? Okay. I dislike the fact that we're not going to get to do the project now, but that's, you don't even know what you're missing because you never had it, so.
What's the last day of school?
June 6th.
Are you a senior?
No, I'm a sophomore.
I have no idea how old people are. June 3rd?
Wait, is it different for sophomores and seniors?
Yep.
Oh, it is? Like, how different?
Seniors leave
I think one day.
earlier.
I think seniors' last day is June 1st or 2nd.
Wait, why is it?
I think it's second.
Second?
I might be wrong.
Yeah, I don't know. Who in here is a senior? When are you guys done?
I don't know.
How you do not know that?
Well, because like it's so close to the point where like, I don't even know how to do it.
Yeah, it's not much earlier. I know
It's
that.
like, I know in the past they used to leave like a week earlier, but like us, it's like a day, so it's like, it doesn't matter to me.
Yeah, I don't know. Okay. Well, feel free to ask me about it, or whatever, if you want to talk to me about it later. So we're on the next section, and honestly, I feel like it's not going to go that bad at all for you, because I've been trying to prep you for majority of this information ahead of time, and so I think that's why this section will go pretty good. A lot of integration, the topics kind of overlap and things like that, so it's, until we get to something super specific, it all kind of blends together, and so that's why I've been trying to just teach it to you as we go. So this is what you guys had a couple sections ago, which we didn't really do much with because you really didn't know how to yet. So every other textbook I've been a part of, this was called the second fundamental theorem of calc. And I know in this curriculum it calls it part 1. But this is what we had a little while ago. And it basically says the derivative of the integral is what you started with. And so that's the part we talked about. Okay? In all the other textbooks I've ever had, this is called the fundamental theorem of calc. On this one, it's called part 2, but it doesn't matter which one's which.
This is so if you don't have a test, what other homework do you want to do?
It's a great question. Yeah, we probably should do that, because otherwise I know some people will just kind of abandon it altogether and then think that they're somehow going to procrastinate and do all the homework like half a week before the tests or something. I don't know. I don't know. What do you guys think? Would you like me to have periodic due dates for homework so that you get it done, or would you prefer me to just like check your homework when we get to the test?
You could already, I think periodically.
The downside about the homework is your guys' grade is really not going to look like an accurate grade until we take a test. I don't know if it's going to matter or change anything, but still, just so you guys know. But just in my experience, if I tell you that homework's not due until May 13th or something, nobody's going to do it until
May 12.
Yeah, and that's usually not great for calc. Yeah, I just, most people have natural procrastination built into them. And so I think if we just have periodic due dates, that'll help you guys maintain it. Yeah, sure. Let's just say April 11th, chapter 6 is due, because that would have been the day of our test. Sure, I'm good with that one. It's a good question. So the fundamental theorem of calc is basically just how we're going to actually do definite integrals with equations. We've done definite integrals a lot with pictures because a definite integral represented the area under the curve. So we've done it a lot graphically, but not actually analytically, which is an equation. So what you're going to do, and if I kind of translate this formula for you here, f of x would be the function we are integrating. Capital F would be the answer you get from integrating little f. Like we've mentioned that part before. And then the way you're going to find the answer is you're going to plug the top number in capital F and then subtract the bottom number plugged into capital F. So you're going to take the equation you get as an answer and then plug in the top number minus plug in the bottom number. Biggest mistake by far that I've run into for students is they'll accidentally forget to integrate first, and then they'll just like plug the numbers directly into the equation. So you have to integrate first. This stands for net change and displacement, if you ever run into those terms. The definite integral stands for that. Right here, I'm going to kind of skip around because these notes were kind of laid out weird to me. That is the notation you're going to see, or that I'll write for sure, is you integrate the equation, so that's what capital F of x means, and then you're going to draw this bar directly after the equation you just integrated, and then write the two numbers that you need to plug in. So if you run into this notation, that's what that means. That means the equation has already been integrated, but you haven't plugged in numbers yet. So let's do one together, and I'll kind of guide you through the way it should be written, I guess. I think the integration part itself, it seemed like it went pretty well for you guys yesterday. I don't know. I didn't get an awful lot of questions in class, but I don't think we really had that much time either, did we? I feel like it was like 15 minutes or something. Okay, either way, let's integrate x squared minus 3 from 1 to 2. So x squared is a power. It's a variable of the power, so I would use the power rule. So I add 1 to the power, divide by the new power, and then now I'm going to minus and integrate 3. So if I integrate a constant number, I'm just going to write that number with an x after it, or whatever variable you're using. Here's going to be the main difference. I don't need to write c anymore. You can write c if you want. And I'll show you the difference afterwards. But if you're doing a definite integral, there's no plus c, because it doesn't actually matter what c is. And then we're going to use 1 to 2. Plug in 2 first to get an answer. So that would be 2 cubed minus 3 times 2. Minus, and then plug in 1. And if you want me to write a little note for that below it, I can. 1/3 minus 3. You will definitely see that integrating gives tons and tons of fractions. Plug in 2 minus plug in 1. Really mathematical exact terms. Mm. 8/3 minus 1/3 would be 7/3. -6 plus 3 would be -3. So that is 7/3 minus 9/3. So -2/3.
Yeah.
And then if you were unsure if you did it correct or not, I believe I've already gone over to show you guys how to check that on the calculator. Yes? No? Okay. I don't know. Any kind of questions up there? Notation you didn't really follow or something that didn't make sense? Anything? Yeah, did you fill out the thing already? You just fill it out of the way. It should automatically approve. So. Is this not bad? Easy? I don't know what. You guys give no reaction. Okay. Do you want to try B on your own? Okay. Try B. Oh, I didn't have anybody. I'm going to be the roller today. I haven't even gotten to roll the new dice. I'm hoping you also noticed that the numbers that were chosen were convenient to work with roots. So that's kind of on purpose so that the answers don't come out terrible. Do know, if you guys do one of these problems and the information just not compatible, then that's what you leave as your answer. Okay, Lily, you got rolled. Anything you can tell me to start. You don't have to do the entire thing.
Or write the square root as 3x.
Good. Okay. So we're going to integral 1 to 4, 3x to the half. Well, that's so hard to write small. Okay. Is that where you got to, or you more?
And then add 1 to the exponent.
Good.
Do 3x.
Good.
And then do times 2/3.
Good. And then I'm just going to leave that 3 there and do the 2/3 in front of it. And then you can write, oh, I didn't show you that. I forgot that part. If you guys write plus C at the end of it, it's not going to be marked wrong. You just don't need to do it. If you write plus C at the end of your equation, what you would end up with is a plus C minus the exact same plus C. So the C's end up canceling out whether you write them or not. So AP doesn't require you to write plus C on a definite integral. Okay, so perfect. And then we would just write the numbers here. Let's go with somebody to answer this. 1, 2. Anything you can tell me here?
Plug in 4 and then subtract it, and then you plug in 1.
Good. So I just simplified it a little bit. So I'm going to plug in 4. So I would have 2 times 4 to the 3 halves minus 2 times 1 to the 3 halves. Were you able to calculate that? Oh, okay.
14.
Might be correct. I have no idea. I didn't do it either. So 4, the 2 on the bottom means square root. So square root of 4 is 2. Cubed would be 8. Times 2 would be 16. 14 is sounding like a good answer. Square root of 1 is 1. Cubed is 1. Times 2. Nice job. So if you guys got 14, very good. I don't know if you feel like you want to do a lot more of these together or not. I'm open to it either way. Yeah.
When you put 2 over, when you put like multiplied by 2 on like the second step, where it's 2 times 3x.
2/3 times 3.
Oh,
Yep.
yeah. How'd you get the 2/3?
Oh, so when we added 1 to the power and got 3 halves, you're supposed to divide by the new power.
Yeah.
So dividing by 3 halves is the same thing
Oh.
as multiplying by 2/3.
How would you do C?
C?
Yeah.
Okay. So when I'm looking at C, that's squared. That squared kind of messes things up. And you don't know how to integrate this yet the way it's sitting. So what we could do is we could rewrite it by just foiling it out. And we could write it as 4x squared minus 4x plus 1. Is there any other weird ones here? E. That one definitely is.
You just move it up and multiply up. Like,
You can just move it up, but it's still kind of strange. E. Whoops. E, I guess I would probably write. Oh, no wonder why I'm pushing the button. My pen is messed up. There we go. I would probably write this as square root of 2 separate times, and then you're correct, I can bring the x up. Or this is like saying the same thing as square root of x on the bottom of a fraction. So it's x to the negative half. It's written really strange, and you normally don't see it written like that. But a square root you can break apart into the top and bottom being separate. And then that would just be power rule. Okay, should I move on or not? Or do you guys want some more practice on this? You have very little opinion today. I have one opinion. Does he speak for the other 34?
yes, that's what.
Wow, okay. Is the news about the tests really bad and you just don't want to say so, or?
No, I think it's a
Kind
good.
of mixed. It's like I don't know how I'll feel on the week after these.
Oh, I get it. I mean, I don't want to do it, but we were trying to figure out how to teach you everything. Should we talk about one of these? Sure. Let's look at B. Pizza's always relatable. Although, how many of you have actually made a frozen pizza at this point? Not many. Wow.
I feel like some people just don't want to put up their hands.
It's one of the simplest things ever to make.
I'm allergic to cheese.
Like stuff in it?
Yeah, cheese.
Oh, I feel bad for you.
Allergic to milk too.
Weird.
Yeah.
Hmm. Why don't you just make a pizza without cheese?
Why don't you make pizza without cheese?
Because the dough also has milk in it.
Really?
Yeah.
Oh, I've never made dough.
So I made my pizza from scratch.
Isn't dough just water and flour?
They add some other stuff. Some people add eggs, some people add milk.
Oh.
Make it rise.
Yeah, I'm not going to try to pretend like I'm any kind of a cook in any which sense. Okay, so if RFT represents the rate at which your pizza changes temperature in the 475 degree pizza oven, 5 minutes after the pizza had been placed into the oven to cook. I don't know why you would have an equation that represents this, but it doesn't matter. I feel that might be overkill. What would the integral of the rate of change of the pizza stand for if we're integrating from 5 to 20? Teddy, I think I heard you say it. Even though you like didn't want to say it to everybody else.
Like the total change of 10.
That's it. Perfect. the total change in temperature from 5 minutes to 20 minutes. So the numbers that are on the integral represent what you're actually looking at. So for all you know, the pizza was 300 degrees at the 5-minute mark, and at the 20-minute mark, I don't know, I would assume the pizza would be 475 degrees at the 20-minute mark, but who knows? I suppose it's actually a little warmer than 475, because wouldn't it like soak up some of the heat? These were some of the projects that we used to do after the AP test when we had a lot of time. Is people that liked food or liked to cook would do Newton's law of cooling problems, which are in Unit 7. But they would do those, with different kinds of foods to test, the rate of change of cooling of different things. Like brownies, how thick you make your brownies actually affects quite a bit in how they cool off, / like how crunchy they get on the corners and all that kind of stuff. Or people that used to drink a lot of coffee, people that go to Starbucks all the time. There's a different rate of cooling between the different brands of coffee. Like between Starbucks, Caribou, McDonald's, they all cool off at different rates. So, whatever. Totally unrelated to this, but still. I'm going to do this first one with you guys, and then I'm going to move on to the next page because I don't like this setup, and I'll show you why in a second. I know the purpose of this problem was for you to actually integrate this and then take the derivative afterwards and find out what you get. I don't know, maybe I should do it with you now that I said it out loud. Sure, let's do it. We got time. I was almost thinking we could do this entire section today and give you guys time to work tomorrow, because I'm sure some of you need to catch up from the last section, possibly. Yes, no? You guys are awfully quiet today. You make it very difficult to teach. Oh, I forgot tomorrow's wind schedule. Never mind. I can't give you the whole hour to work tomorrow.
Yeah.
It'd be 85 minutes. Do you guys meet tomorrow?
No, we meet Thursday. We could just.
You are the lunch period on Thursday. FYI, you guys have a lunch. Okay. Either way, I think we'll still finish today regardless, but I guess we'll have to figure out a schedule. Oh, I've got the roller. I was going to wait for somebody to roll. 4-8. Nobody. Three, 1. All right, Amelia? Can you integrate cosine for me? Okay, good. And then instead of me writing plus c, I'm going to put in the bounds, pi to x. And I'm going to plug in the top number, which is going to be sine of x, minus the bottom number, which is sine of pi, which is 0. Okay, so I integrated it, and I got sine of x. Now this brings me to the next box, which is to take the derivative, which is 4-3. Oh yeah, perfect. Third desk. What's the derivative of sine of x? Okay. Now here's what we're supposed to get out of this. If we take the derivative of the integral from pi to x of cosine, we get cosine. Shouldn't be too shocking. The derivative and the integral cancel each other out. What we're going to find on the next problem is it doesn't work out perfectly, though. There's adjustments.
Is there a difference between the x and the t?
Yep. You can't have an x in both spots, so that's why they put a t as kind of like a temporary variable.
But if you're actually evaluating the integrals like f of 3, you like put it in place of the x and the t? Plug the 3 into both, or would you treat
What
it
3?
I'm just like
A made
giving an
variable.
example.
Oh.
If you were to-
So see how it says f of x?
Yeah, so you
Only put it in place of x.
so then what do you do with the t?
So you would have to integrate and keep t as a variable, but then that 3 that you plugged in place of x would get put in place of t when you do the definite integral. So it would get replaced at some point. Okay, we're a little bit harder now. You guys aren't going to know how to integrate that. That was a terrible example.
Rewrite it.
I know, I'm trying to think if it would be easier if I just rewrote it. Now I remember why I thought this section wouldn't have been good for us to do. How about I just tell you what's going to happen, rather than struggling through all the different parts you're not going to understand yet. Okay, the derivative of the integral does cancel itself out, and effectively what happens is you just take whatever was here and put it in place of the variable. And we did that. Okay, well, something similar is going to happen here. If we do the derivative of the integral from 0 to x cubed of square root of 1 plus t dt, the answer is going to be us taking and putting x cubed in place of t. So we get square root of 1 plus x cubed. But then we have to multiply by 3x squared. Because when you take the derivative, we have to use chain rule. Right? And let's say we integrated, and you get an equation that you guys don't know yet. That's squiggle. We would plug in x cubed, and then minus plug in 0. So you would have an equation with x cubed plugged in it. And then we would go to take the derivative, which requires us to use the chain rule, because we would have x cubed in place of the normal variable. And so at the very end of the problem, we would have to take the derivative of x cubed separate. So that's what ends up happening. We okay with that? Okay. So then we get to a more complicated one. Any guesses as to what the answer is going to be? If we do the derivative of the integral from x squared to cosine x of sine of t dt.
Negative cosine x sine x.
It's going to be sine of cosine of x times negative sine of x minus sine of x squared times 2x.
Oh, yeah.
Thoughts on where that came from?
It came from,
Why is the one set of information written first?
Because that's the t.
Because it's on the top of the integral. The x squared was on the bottom of the integral. So the whole definition of a definite integral means you're going to integrate sine of t, plug in cosine minus plug in x squared. And then you would take the derivative of both sets of those equations. So up top, the very first one we did, it's much easier because it was just an x. So the derivative of the integral does cancel itself out, but the whole idea of a definite integral is you have first one plugged in minus the second one plugged in, and then when you take the derivative of the first one, it's got variables. So derivative of variables is stuff. Second one would have been a derivative of numbers, which would be 0. And so it wouldn't show up in this answer, even though we would have had a minus 0 at the end. Same thing actually happened to the second one. When you do the... I thought of a better way to display this instead of a squiggle. This definite integral would have given us the integrated equation plugged in with x cubed minus the integrated equation plugged in 0. And then if we're taking the derivative of capital F is little f, which was the equation we started with. And so the derivative of capital F of x cubed would be little f of x cubed times 3x squared minus little f of 0 times the derivative of 0, which is 0. Was that helpful to see it that way? Or not?
That makes more sense.
Okay? I mean, like, even if you don't know how to integrate the equation yet, this is what took place. And if we did the derivative of a composite function, then you're going to take the derivative of the outside and then the derivative of the inside. The derivative of the outside would be little f. Derivative of the inside would be 3x squared. This is technically the notation, but I thought this was horrible looking. That's why I thought I would try the problems first. That's awfully long, isn't it? It's technically what I just said. You plug in the top equation, minus plug in the bottom equation, but since you're doing derivatives, here I'll underline what I'm talking about as I do it. You plug in the top equation, minus plug in the bottom equation, but since we are doing derivatives, you have to take the derivative of the inside at the end. And yes, these questions are much easier once you get it straight in your head. It's probably going to take a little while to do that. Yeah.
So if we're trying to actually evaluate it, that's not the antiderivative, right? That's just the derivative of the antiderivative? Well,
Yes.
So they cancel each other out.
So like f was the original function
Yeah.
we started with, and f is like the guiding function that you would use.
But when we're evaluating, it's like the antiderivative with b plugged in minus antiderivative a plugged in. So what would we do with that?
When you do the derivative of what you plugged in, that's what this is. Doing the derivative of having something plugged in requires the chain rule.
Yeah.
So that's kind of what's being shown. The notation is far worse to look at than actually doing it. Let's do number 4. Let's roll somebody so you don't fall asleep. You guys right now are on food comas. I can't pick up this dice, it's too small for me. 1, 8. Nobody? Maybe I should have just said 9, make it easier. 1, 1. Do you think you could help me figure out the derivative of the integral from 0 to x squared of e to the t squared dt. And if not, I can guide you.
Plug in. Would you have to take the integral first?
Nope.
Okay.
In fact, you wouldn't even know how.
Then plug in x squared
In place of,
in place of t.
good. So e to the x squared squared
And then you would have to take the derivative of x to the fourth. Or-
Close. Just the x squared. Yep, just the x squared. And then is there going to be a second half? No, because it was just a number. So the derivative of 0 would still be 0. So this is technically minus nothing. But you don't need to write that. The derivative of the integral just cancels itself out. But because we're doing a definite integral, it's got details in there. Stuff we plug in. So we do the top minus the bottom. And you stay with the original function that you had, except for you have to plug things in because derivatives use chain rule. Was anybody able to figure this one out on their own? I mean, I don't even know if you're able to say this yet either, but like, I'm sure there are parts of it that are confusing to you. What parts? Like, I'd be glad to try to explain something in specific. I don't know what part is throwing you off. What time is it? 52? We get it done at 4?
Yeah.
So wait, like regardless of what number it is at the bottom, it's gonna be 0. Is that what you said?
Nope.
Or
If it's a number.
if it's a number.
Is that both the top or bottom?
Yep.
So if A is in the top, and it's a number to the bottom, it's first be the second part. So like 0 minus whatever. Yeah. I feel like if I was a bit more realistic, I would understand it. I get some parts, for most parts.
So those two problems look very similar. But they're actually very different to figure out. So the top equation is an indefinite integral, which would mean you would just integrate the equation and then take the derivative of it. And there's nothing like, that's just kind of it, right? Not to say it's easier, just that's what you're doing. And so as an idea, the derivative and the integral cancel out cleanly. And this would just become sine of square root of x. Like there's nothing more to it. If you have just a regular derivative, regular integral, they cancel each other out cleanly. The bottom one is a definite integral, which means you would be plugging in information during part of the process. And so the derivative and integral still apply, and so the answer is still sine of root whatever. But where it differs is that this is the information you're plugging in. And so I'm still kind of doing that. Because that's what a definite integral does. It means I would plug in top minus plug in bottom. but the derivative process itself, like that's what we did so much of. And I think you guys are decently used to chain rule. So I do that at the same time. I'm going to plug in 5, but then I have to take the derivative of 5. I'm going to plug in x cubed, but I have to take the derivative of x cubed. Derivative of 5 is nothing. So this whole term turns to 0. Derivative of x cubed is 3x squared. So I end up getting sine of square root of x cubed times 3x squared. And then this would be my whole answer. Like, they're done similarly, but you just have to take into account the fact that a definite integral means plug in top minus plug in bottom. They do have the same style answers, but the one on the top just has so much less to do with it. So that's why it's considered like clean and easy. Does this kind of help separate it a little bit, I think? Okay. That's what you're doing. You honestly, you don't very often do the derivative of the integral. It's not a common thing, but it's just part of, they call it the fundamental theorem of calc because derivatives and integrals are the two things that make up calc. And so as an idea, those two things, when you apply them to each other, cancel each other out. It's just the two things we do in calc. Okay, I'll stop there. Honestly, there really isn't any more notes if I remember right. Yeah, I guess we could. Well, this is just here because it's a piecewise function, not because it has anything to do with equations. Do I even need to tell you how to do this one? Oh, okay. Integral 3 to 8. I have a picture, so I would use my pictures. We're told from the equation that it goes on forever past 1 and goes to the left forever before 1. Our picture just stops. Like those are arrowheads. So I would know I had to have a rectangle that's 5 high by 3 to 8 would be 5 wide. So I'd have, I guess, a square. And my answer would be 25. Because we're going graphically, it's just area again. Now, I know the intention of this problem is to tell you that because we have a piece function, if we are trying to find the area over where the piece function breaks, then I'm going to break up my integral. So I'm supposed to stop at 4. But I obviously have a part in the middle there where it splits. So what I would do is separate my integral to go from -2 to 1, and then use 3x squared, because that was the top equation, plus the integral from 1 to 4 of 5, because that was the equation greater than 1. And then that way you could evaluate them as equations. Well, I really didn't give you much time. I'm definitely going to need to ask a lot of grace and forgiveness for you by the time we get to the AP test as well, because my brain is going to be quite thoroughly burnt out from trying to teach calc that much every hour, all the time.
Wait, was that all 6.6?
Yeah? 6.6 would have been a lot more difficult if I hadn't talked about some of the stuff ahead of time. Like I kind of brought up definite integrals, topics.
For like 85 minutes we're getting, are we doing all 6.7 or?
I'm hoping so, but I don't know.
Okay.
I'm not. I also know that it's really hard to listen for 85 minutes in a row of Kelk. So, yeah, I mean, like, in theory, we should be able to teach more, but I also get that your brain only holds so much per session. Like, a lot of times, if I remember right, I think research shows you're supposed to, like, stand up, like, every 15 minutes.
Yeah.
Because 15 minutes is like a time span for your brain. But even school hours being 1 hour long don't really allow that.
A lot of teachers.
So we didn't even, I knew we weren't going to have enough time at the beginning of the year because of the various days as it was. So we don't often get to just like take breaks.